Hi gang, I apologize about tonight. As you can see, I am a Mac user finally, and I'm having some major difficulties trying to figure out how to use how to use a Mac with Blackboard Collaborate. I had it down, I had it working earlier today, but there's some problems here. So anyway, decided to just kind of do a quick recording of some key topics tonight. I wanted to thank Megan, Lauren, and Katie for coming up with some pretty good looking handouts. So thanks for that. Let's review some key content here. Let's start with just a brief review of math and we'll get into behavior. The agenda, we'll keep it simple. We'll talk about some key math issues. We'll go really quickly through that. And I'll focus on some sort of new points that we didn't get to last week. And then I want to talk about this idea of behavior. Okay, so let's go through some ideas. I want to start with a slide that you've seen before. I want to draw your attention to this idea up in the top right, which is the idea that curriculum is a task-specific, not a task-specific behavior, but a set of task-specific behaviors. So as you see, what we've seen here before is that yellow and blue make green. Okay, so we have our phonological awareness, our knowledge of sounds and language, and then we have our knowledge of letters and words. Okay, so with the letters and words and the sounds, when they match, we have the alphabetic principle, the green. That is covered in Howland Nolet's chapter on decoding. Okay, over to the left, leading up to the top left, essentially, are the chapters on vocabulary and comprehension. Okay, so as we learned, vocabulary and comprehension build through wide exposure to language, both spoken language and written language. So you see the substantial dependency that oral language development, reading comprehension have as it comes to the English language arts curriculum. So if we think about decoding as learning how to figure out what letters say, and then when letters go together, what words say, right? Being able to read words or decode words. What about encoding? So encoding would be the spelling and the writing aspect of things. Okay, so I want you to think about curriculum as task-specific behavior. Now that's relevant to tonight's content because tonight's content we talk about task-related behavior when we're talking about behavior. So let's just do a quick review of some task-specific behavior in math. Okay, so there's some policy initiatives that had been intended to address the problem that you read about last week in Schmidt, Huang, and Kogan, and that is the mile-wide, inch-deep curriculum. Okay, so in 2006, up here in the top left, in 2006 we had the curriculum focal points, and that took a very large, what you would call a mile-wide, inch-deep curriculum that had a number of different topics in the area of math and pared it down to three, pretty much number concepts, measurement, and whole number meaning, very much like Schmidt, Huang, and Kogan talked about. In 2008, the National Math Panel came out with their findings and talked a lot about, most of this book was about preparing children to understand and be successful in algebra. Okay, so the notion of algebra is really about finding the missing quantity, okay? Finding the missing, not necessarily a missing number, but solving for x, solving for that thing that we don't know. So even very basic math, 3 plus blank equals 6, well, that blank we know is 3. That's the very root of algebra in a lot of ways, okay? Solving for that unknown quantity. So along came some other policy initiatives, the Common Core State Standards, and early childhood initiatives in early math. And what we have today is this real strong understanding that mathematics, as it says here, are critically important to children's success in schooling, and not just success in schooling, but as we're finding out more and more, that the extent to which children are successful in math, both early on in schooling and later on in schooling, really predicts whether or not they're going to stick around or what you might call be retained, right? Will predict retention rates when they enter college. So students that are at risk, or students that typically don't do well in mathematics, typically don't do well because they are at risk, right? Will to some extent experience resilience through or as a function of math skills. And that was shown by not just Duncan, Dowsett, Claessens, and Magnuson here, and others, but also Borman and Overman in 2004 demonstrated the resiliency in mathematics. So we've seen this before. We've seen this idea of a coherent math curriculum, all right? So you read the Schmidt, Wang, and Kogan paper. So we see in front of us a coherent curriculum. We have these A+ countries that early on focus on foundations, building strong foundations, and then widen those foundations out as the grades go along. So just a quick look at this graph, you get a sense of what these A+ countries are doing well. And then you have the United States. And the United States tries to pack, there we go. The United States tries to pack everything together in, again, this mile-wide, inch-deep curriculum. So you even see in grade 1 how teachers would struggle to cover the curriculum over the course of a year, and how students would struggle to learn the curriculum over the course of a year. Now, what's the problem? As I mentioned last week, one of the problems is we just don't know enough about math. You hear that a lot. So this was a graph from a paper I published in 2011 that really operationalizes for us the lack of research in math, and how we really need to catch up, not just catch up to reading, but to early literacy and to reading, but to catch up to the curve and to really figure out what math is, so that the content of math can help us with the curriculum. Now what you see on the screen now is another graph from that same paper, taking a look at the different assessments that are out there in math. Okay, so the assessments that are available in math sort of look like a mile-wide, inch-deep situation as well. Okay, we have up here, we have about 20 different types of math assessments. Yet we don't have any frameworks for really putting them together, like content frameworks. As we remember Judy Laughlin's Yellow and Blue Make Green early language curriculum that we started with today, right? That's a really nice framework, the notion of orthography plus phonology, or letters plus sounds plus oral language equals comprehension, which then equals, to an extent, writing and spelling. Okay, so we have these nice frameworks in reading, but we don't have them in math. We have this sort of mess, this shotgun approach to math. Well, that's changing, and it's changing quickly. What people say, and you might hear this a lot, is, well, math and reading are very, very different, okay, so we can't approach them thinking the same thing, but maybe we can. Okay, so take a look at the alphabetic principle. The alphabetic principle, as I mentioned, the meaning system right up at the top, you see semantic system. Just think of that as a term for comprehension. Well, comprehension and meaning is it really empowered by and gives what you might say action potential to students' phonological lexicon and orthographic lexicon. Now, a lexicon is simply a collection of information, or dictionary, if you will. Okay, so just let's think of a kid who is learning how to do sounds for the first time, or rhyming. Okay, let's say a 4-year-old who's rhyming. Now, that 4-year-old is motivated to rhyme and to understand what rhymes mean and how to do rhyming, how to put letters and sounds together, how to read words by this sort of cognitive tendency, or let's not even call it a tendency, this sort of cognitive goal to make meaning out of the world. Okay, so the semantic system that you see up there puts into play the notion of letters or orthography plus sounds as represented by phonemes and graphemes. Phonemes being phone, think of the term sound. Think of the term phone, or the word phone to help you understand the idea of phonemes, and they're really individual speech sounds. And over on the right, graphemes, or graphs, things that are written, letters and sounds. All right. So we have this in the alphabetic principle that we know about. Well, do we have something like that in math? Well, sure we do. We absolutely do. We have at the bottom this number form. Okay, so we have the symbol, very much like the orthographic lexicon or graphemes. So we have the visual aspect. The top over on the right side, we have the sort of analog aspect, the thing that number really is. So this is a neat time to think about the difference between numeral, okay, which would be the visual aspect or the orthographic aspect of math, and over on the right, the magnitude. So not just the numeral at the bottom, but number, the idea of number being very different from numeral. So 3, the numeral 3 represents 3 things. Okay, 3 objects, 3, looking around here, wheat thins. I have a bunch of wheat thins here. So 3 wheat thins, okay? But remember, we're not done yet. We have this triple code according to Stanislas Dehaene. You see his citation below the below this this slide over on the right. Okay, so it's not just enough to know numerals, and it's not just enough to know magnitudes and quantities in the early math curriculum as a foundation. We need to know the words, so there is a language component as well. This is what you would call the number sense access view. For children to have access to the idea of what school math is, they really need to have teachers and curricula, teaching, curricula, or teaching and instruction, let's put it that way, teaching, learning, and instruction. Teaching and instruction needs to be focused on these 3 ideas. And starting with the most obvious to children, which would be the words, and then the object, and then sort of a fading in of the numerals over time. Or what special education teachers call concrete, representational, and abstract. Okay, so we start with the concrete, move to the representational, which is how children represent numerals, represent the idea of number with drawings or sketches or dots, and then we move up to the idea of formal numerals. Okay, so here's another way of thinking about it. This was a schematic that I had in the 2011 paper that I had cited. My 2011 paper. And if we do start with this quantitative magnitude code of, let's say, 4 things, we see them right here, okay, what comes next? Well, we've got that language down, so we start to make links between 4 things and the word for as we move along, okay? And then as we move up, we start to realize, well, these 4 things that we saw before, oops, oh boy, hang on. These 4 things, as we saw before, can be represented with a numeral 4. Okay, so this idea that access to numerals builds over time with experience, and experience in school math is definitely an important idea. Remember, the kinds of things that school focuses on, the numerals, are very challenging for children that don't have these foundations in number. Okay, so we think of early math, representational math, concrete math, representational math, and symbolic math. Okay, so a neat way to think about math is thinking about math as informal. Okay, so informal numeracy or informal math that is very much focused on language and objects. And then this notion of formal math, not, I would say formal as a basic contrast the idea of informal. Not formal because it's challenging to understand that the numeral 4 is 4, but the idea that formal schooling, that is kindergarten entry, brings about the expectation that children know and can work with, can manipulate numerals, can put 3 and 4 together to get 7, to break 7 down into 5 and 2 things. Okay, so the notion of alphabetics is very similar to the idea of mathematics. And the informal to formal model is very useful. Now, it's not only very useful, it tests well. So this is a paper that I'm trying to get published now, and that this is a model what you would call a confirmatory factor model. Okay, so I took 5 tests of early math, starting at the top left, oral counting, right, asking children just to count. Another test called ordinal position fluency, and that is showing them 5 things, asking them to point to the 3rd thing. Tell me what place something is in the picture that they see. And then we have equal partitioning. So over on the left, now equal partitioning would be something like there's 4 dots and or 4 candies, and we want an equal share between these candies, or Tommy and Johnny want to share the candies. How many would they each get? So we ask children to partition that, and that's a very early idea related to this very important notion called the part-whole concept. Now over on the right, we gave some tests. One of the tests was a missing number fluency, and children saw things like 13 blank 15, 4 blank 6, and then the last test, MQF, match quantity fluency, they saw a numeral and different groups of dots, and they had to point to the groups of dots that corresponded to the numeral and vice versa. Sometimes they would just see one group of dots and a bunch of numerals, and they would have to choose the numeral that corresponded. So what this confirmatory model says in front of us is that these 2 content areas, informal and formal, they separate out very nicely. The model of informal and formal number sense is quite tenable. So it's an important way to think about the math curriculum. Now, what we also did is say, well, is there a second order factor that's shared underneath formal and informal number sense? And there absolutely is. You know, there's this higher order factor that many have called number sense. All right. So these tests can represent the factor of not just the factor of number sense, but the disaggregated bifactor of informal and formal number sense, right? And if this looks hard to understand, this confirmatory model, just remember up top in the little boxes there, in the squares, you simply have tests that were given to children, okay? This is a neat conception here. What we have on the screen is a very neat conception from Doug Clements and Julie Sarama in a book that they put out in 2004. And look at this. This is really a concept map of the number and operations strand. And if you look very closely, you'll see that counting up in the top left area has arrows only going out of it, meaning that counting feeds into the ability to compare and order numbers. And then comparing and ordering numbers feeds in to adding and taking away, and then composing sets and decomposing sets. So this is a really neat concept map, but it looks very confusing, okay? It's not as nice as what we saw over here with this neat informal and formal structure, okay? So one of the reasons why Ginsberg and Baruti put this informal and formal structure together is to help teachers really make sense out of what is this thing called math. Okay, is it this thing up here, this hodgepodge of pieces of information, or is this nice hierarchical cluster of key skills that build upon each other over time? And the answer is the latter. Okay, so that was math. Let's move on to behavior. Now, the same thing with mathematics. I guess since we're talking really in this class about broadly ELA curricula and math curricula, and now the behavior curriculum, out of all of those 3 areas, you'll hear me use the term, let me just do a quick aside, you'll hear me use the term curricula, which is simply a plural of curriculum. I apologize if I'm using it interchangeably. But now back to the topic. Out of the 3 areas we've studied, ELA, math, and behavior, one might say that ELA is the best developed of those areas. Okay, so we're not spending a lot of time on that, or what you might say is we're spending a lot of time on that, but it seems to be a very coherent picture that we put together after we pick it apart. Now, with math, we're starting to see, okay, maybe there's a little more coherence out there in the world than there was. What about behavior? Okay, so one of the things I want to do briefly tonight is first just kind of, as the first bullet says, introduce us to the problem. And the problem here is that there's a lack of a behavior curriculum. What I want to do is, well, we can't do this since we're not live, but there's a can't versus won't video that helps us really start to think about what behavior is. So you'll notice how Howell and Nolet like to break up these ideas into task-specific and task-related. Okay, well, the can't versus won't framework breaks things up into skills and then performance. So it's more broad-based overview of task-related behaviors. Okay, so we could say for math, for reading, all of those task-specific behaviors, we can say within English language arts or within a specific reading task, you have a group of children who seem that they can't do the work, that have acquisition deficits. Now, in the same group of kids, you could find children that have acquired the skill, but aren't motivated to perform it, the notion of won't. Okay, so this idea of can't versus won't, very important to the behavior curriculum, or task-related behaviors. And Lauren did a very nice job in spelling that out. So with regard to where to go after the can't versus won't framework is taking a look at the different kinds of models and frameworks that are out there. Okay, so can't versus won't is one. What's another one? Let's take a look down at the bottom here. So, what is behavior? How can we distinguish and define behavior so that we can really help children, help teachers understand how to help children who have quote-unquote behavior problems? So the three areas that I highlighted we'll go over a little bit more in depth when we meet together again. The first one is Steve Kilgus, and that's his SABRS model, right? SAEBRS, and that's social, academic, and emotional behavior rating scale. One of the big questions underneath all of this is, if we lack a behavior curriculum, which we do, and when I say we, I mean schools in general, and that's understandable when we look at the different state websites. You see the task-specific kind of curricula abundantly available. The task-related curricula, that is curricula for the area of math, curricula for behavior, are usually embedded into task-specific curricula, which is fine. Quite honestly, the Common Core has a set of what you would call practice standards, and that is you can look at a student's perhaps engagement or motivation in the task of math as an indicator of whether or not that student has successfully proceeded through the task-specific curriculum of skill development, and then not just skill development or acquisition of skills, but performing those skills in a way that makes sense. Now remember, the teachers, the curriculum are responsible. School curricula and the way that teachers teach that curricula really are responsible for how students learn math. So we have Kilgus, who talks about the social, academic, and emotional aspect of behavior, right? That emotional aspect related to what you would think of as internalizing behaviors, okay? So there's so many neat ways to break up behavior. One of those is not just can't versus won't, not just social, academic, and emotional, but internalizing behaviors and externalizing behaviors. It's another neat way of thinking about it. So we know the Howell and Nolet, which is that first bullet there, task-specific, task-related. We just briefly went over Kilgus. Gresham and Witt, we talked about the can't versus won't. We'll take a look at the video next week. And then we have Riley Tillman, Sandy Shafoulias, and their DBR camp, or Direct Behavior Rating Camp, that look at really three behaviors. That is the extent to which students are respectful in the classroom, cooperative, if you want to call it that, engaged in the task, and more or less disruptive. So rating those three behaviors, or curricula content related to those three behaviors, help us really define what behavior is. Now, this notion of CARES is the social skills rating scale, and associated curriculum that Frank Gresham and Steve Elliott put together in 2001. Personally, it's my favorite model of social skills, right? We had a neat handout tonight. I'm pretty sure Megan put the social skills handout together. Now I might be getting Megan and Lauren's handout confused, but I do know that we had 2 chapters, one on social skills and one on task-related behaviors. Now the bottom, Gresham and Elliott, the CARES model is cooperation, assertiveness, responsibility to others, empathy to others, and self-control. And self-control very much related to the idea of impulsivity, which we've heard about in psychopathology courses where we study attention deficit hyperactivity disorder. Okay, so this is how we get specific with math. Now, this is how we get specific with behavior. I would want you to think about which one do you identify with, which area pulls you in, which one of these notions, task-specific, task-related, social, academic, and emotional, which one of these sorts of distinctions or concepts of behavior makes the most sense to you? If you are so motivated to engage in these 2 activities in lieu of having to meet together, now you certainly aren't required because you probably hung around for about 10-15 minutes before somebody saw my email, and hopefully someone notified the class that I just can't log on. So I wouldn't expect that you would do these activities, but if you're wanting to, then these are 2 really neat activities to do. The first one would be to take a look at the Common Core, the practice standards, and take a look if you can find any of Howland Nolet's task-related behaviors in the Common Core. And when I say the practice standards, that's specific, somewhat specific to mathematics. Okay. Now at the bottom, you could type in. I was going to give you some links in class. Over to the left, you could type in Kilgus, K-I-L-G-U-S, and then the Sabers, S-A-E-B-R-S, and you'll be able to find the first 3 or 4 hits that you'll get. You'll be able to find some information about the Sabers. DBR is a website, directbehaviorratings.com, and it's a collection of the research of Chris Riley Tillman and Sandy Shafoulias. And then if you type in the Social Skills Rating Scale, or SSRS, along with the name Gresham and Elliott, you can find out some cursory information about these 3 different kinds of assessments. And one of the questions here to ask is, could any one of these assessments break out and act as a curriculum in an elementary school? Why or why not? So I'd love for you to try to engage in these activities if you can, if you find them interesting. And maybe we'll have something to talk about next week. Again, my sincere apologies that I wasn't able to master the MacBook, but I hope you found this talk somewhat interesting.